still good. This is kind of an out-of-date slide. We are already into phase 3, but phase 1 was when it was Viptela, and it was prior to or right at the acquisition stages. Phase 2 was after Viptela was acquired by Cisco. We wanted to start rolling out our iOS XE version routers, your ISR and ASR series routers. And then finally in phase 3, we've went into data center integration as well. So we are already DNA center integration as well. So we're already in phase 3 now. Okay, so we're going to break out each one of those components individually and have a good chat about each and every one of those. So vBond, vManage, vSmart, and your WAN edge routers. So orchestration plane is going to be first. So if you have one vBond controller, then that becomes your single point of truth. So your orchestration plane controls all of your other controllers and all of your WAN edge routers as well. Like I said, it's not just the WAN edge routers. Yeah, anytime you add a new WAN edge router, he's got to be added to the vBond controller. What the vBond controller does is once somebody, either as a managed service or in-house managed, adds a new router to vBond, vBond communicates that new router now to each of the controllers. So now the rest of the controllers know now about this new router. Now what takes place is this router is being sent by FedEx to the WAN to the branch location. By the time that router arrives at the branch location, vBond, vManage, and vSmart already know that this new WAN edge router exists. And if the administrator has already configured a device template for that brand new router, then this router, by the installer plugging the cables in, he will download his configuration from vManage and be a fully functional router in your production environment. So Chris, I think I answered your question, right? If both controllers are lost, the router would follow its last known config.
Yes, sir, you sure did. I appreciate it.
Good deal, good deal. You guys, do me a favor if you don't mind. I really would prefer that we maintain as close to a, hey, all of us are in the same classroom mode as we possibly can. So if you guys were all sitting in my classroom and I were face to face with you guys, you wouldn't send a chat message to me. You'd just say, raise your hand and say, hey, I got a question. Well, let's do that in the class. Let's promote interactivity. And the reason I want to do that is because if one person asks a question, that could prompt another person to go, well, I have a question based upon that as well. And it promotes interaction, it promotes participation. So I know the chat window's there. And I don't know, Chris, how long ago you posted that message, but it could have been 20 minutes ago. And I just didn't see it until now. So if you've got a question, I encourage you to you just unmute your microphone and interrupt me. Don't worry about, if I'm in the middle of talking, just say, hey, I got a question in mind. And we'll stop and address whatever the questions are and then move on. But I really would prefer having maximum participation in here. And a chat window, especially if it's being sent to just me, then nobody else sees it, right? And so anyway, you guys ask questions as best as you can as we go through this. So as I said earlier, the orchestration plane, your vBond orchestrator, your vBond controller is your first point of authentication. It is referred to as a whitelist model. So if it's a managed service, then the managed service folks will add a brand new router that you buy to eventually to your vBond controller and sit there and wait. Now, you bought that router, so this brand new router now is being sent to the branch location where it's supposed to live for the rest of its life. While it's en route, somebody logs into vManage and adds that by that time, the vBond controller has updated vManage and all the vSmart controllers with this new router's identity information. So this new router finally makes it to the branch location. The installer takes the router out of the box, plugs it in, and powers up. The very first thing this new router is going to do, and the terminology is that it calls home. When it calls home, that means that it is communicating to vBond. So depending upon whether it's a V-edge or a C-edge router, the process is different slightly. So if it's a V-edge router, he will call home to ztp.viptela.com. Now today, that that URL doesn't really exist, right? There's no viptela.anything anymore. So it needs to be remapped within your organization to ztp.yourorganization.com or yourorganization.net, whatever it is, so that when that request goes out, it can be sent to your vBond controller. So that's part of administratively something that needs to change. Now, if it happens to be a C-edge router, that's going to call home to device helper.cisco.com. And where this goes to the plug and play connect portal page. And in here will be where your managed service folks log into, and they add the brand new router that you just bought, your brand new ISR ASR series router, into the plug and play connect portal page. And then via the plug and play connect portal page, it eventually gets added to your vBond controller as well. So either way, it becomes the first point of authentication. So you see, if the vBond controller does not know about your brand new router, or if somebody typed it in incorrectly in the vBond controller, then that new router just simply does not exist. And that first point of authentication then will fail. And if it fails, no subsequent connectivity will ever be even attempted. So in order for this router to be functional, he calls home, he gets whitelisted. If he's whitelisted and is successful, what this vBond controller will do then is he will provide to this router the IP addresses of all of your vSmart controllers and your vManage controllers. So then subsequently, you can set up your tunnels to those devices also. So you see, if this first point of authentication fails, that does not occur. And if that does not occur, he has no clue who his vManage controllers are or who his vSmart controllers are. So this whitelist model, first point of authentication, absolutely required. And if you have vBond, yeah, go right ahead.
What does whitelist mean? So what would you be actually whitelisting? The serial number?
Yeah. So in the vBond orchestrator, you have it's basically it's called. I'll tell you what it's called. It's called it's an organizational name serial viptela file, VIPTELA file. That's the name of the file with your organizational name in there. So that file is a list of the chassis IDs and the serial numbers of all of your routers. So if you've got, let's see, that's 4, 5, 6, 7, 8, 9, 10 routers. So if you add a new router, now it becomes 11. So this file in the ZTP server is what's sent down to vBond, and that's the whitelist. It's a .viptela file name that has your organizational name in there as well.
Right. And you'd be getting that normally from your plug and play whenever it's updated, right?
Okay, so the process that actually happens varies between whether it's a managed service or whether it's an in-house managed service. So I can talk about that briefly for now to satisfy your questions. So you've got a VBON, a vManage, and a vSmart controller. Or at the top level within Cisco, there is a top level ZTP server. And this top level ZTP server has connectivity to your VBON controller as well as to all other customers' VBON controllers when you subscribe for managed services. So if this is a managed service, and this is what you're paying for, right? If it's a managed service, your managed service folks, they buy a router on your behalf, or whatever the terminology is you want to use, but they buy a router on your behalf, and then they log into the plug and play connect portal page, and they will add your brand new router to the top level ZTP server at Cisco. Now, because Cisco's ZTP server knows about your VBON controller, he automatically updates your VBON controller with that chassis ID and the serial number of the new routers. So now you've got 11 routers by chassis ID and serial number in your VBON controller. Your VBON controller automatically will update your vManage and your VBON or your vSmart controllers with this new added router. Now, granted, where's this router right now? The router right now is in FedEx en route to some branch location. It's been bought. The managed service people log in and tell your VBON controller about this brand new router, and then your VBON controller updates your controllers with that new information. So now, when this router finally reaches its remote location, the first thing he does is he calls home. When he calls home, he now is already whitelisted because the managed service folks added this device to the top level ZTP server, which automatically updates your VBON controller. Now, what if this is not a managed service? If it's not a managed service, that means that this is all in-house, right? So now somebody within your organization has to have the entitlement to log into the plug and play connect portal page. And then you would add the brand new router to the plug and play connect portal page by its chassis ID and the serial number. Now, the process of you logging into the plug and play connect portal page now as a customer, what happens is the process generates that .vip tele file that I was talking about earlier, and then you download that .vip tele file to your local PC, and you upload that to vManage, and then vManage updates the vSmart controllers and the VBON controllers. So you see, the process is different between a managed service and an in-house managed service, because, well, not necessarily because, but the result of that is still exactly the same. All of the controllers have to know about every one of your WAN edge routers. But now this whitelist model doesn't really apply to you, does it? If you are indeed an in-house managed service, because you are adding your own router that you just bought to vManage or to the plug and play connect portal page, and you upload that to vManage. And that process you'll be doing in the lab starting this afternoon. So I already have a .viptela serial list file that's got a list of all of our routers in that list, and you'll be uploading that list to vManage. So okay. The process is either you upload it to VBON if it's a managed service, or you upload it to vManage if it's an in-house service. But the result is all the controllers know about this new router. Go ahead. You have another question?
No, I guess something similar happens with Cloud-based appliances.
Well, if it's a cloud-based type of appliance, that's just a managed, that's a service that you're subscribing for from Amazon or AWS, right? I mean,
Right.
AWS or Microsoft Azure. Those would be clouds that you would have to have knowledge of in your production network also. Yeah. A similar process would have to occur, because if that router does not, even though that router sits in AWS, or even though that router sits in the data center at Microsoft Azure, it's still a router you have to be part of your network. And it'll be a virtual router. It will not be a physical router. So
Correct.
you'll have to get the information from AWS or Microsoft Azure on what the chassis ID and the serial number is going to be for those cloud-based routers, so you can also add those to your vManage, your controllers as well. Yeah, similar. It'll be a similar concept.
Okay.
So just know the difference. I kind of went off on a little bit more than what this slide shows, but you know, this whitelist model, that is only if you are subscribing for a managed service, because that's what you're paying for. It's a managed service. Somebody logs into the plug and play connect portal page, and at the managed service folks that you're subscribing for, they log into the plug and play connect portal page. From plug and play connect portal page, they add in the new router, and that generates a Viptilla file that they then upload to your vBond controller, which then also updates all of your vSmart controllers. That's what you're paying for as a managed service. So therefore, if you're not paying for that managed service, then how does that .viptilla file get down to vManage? Well, you got to put it in there. That's what you're no longer paying for. Okay, and more of that will come. More of that will come, but you can certainly see how zero trust, right? If this guy here, when this router calls home to vBond, which it's going to do, when he calls home to vBond on day 0, if he doesn't exist in that whitelist, then nothing else happens. So you see, you can't just throw a router in your production network without following the proper process, making sure that your SD-WAN fabric stays secure. Now, there's a lot more to it than just this whitelist. I'm just saying that if the vBond controller doesn't know about you, no other sequences will occur. You've got basically a black hole router that can't communicate to anybody. No other routers and no controllers until it is available on the whitelist. So this vBond controller, though, if you are setting this behind a firewall, it requires you know, a one-to-one NAT. So if you are doing network address translation for it, and you can have more than one vBond controller. Now, the connectivity between your vBond controllers, though, in the event that you do want some resiliency there, it is, in terms of communications, a little bit different. So if you've got a single vBond controller, then you've got to define who that vBond controller is on all the routers. I got to know who to call home to, right? So, but if you've got multiple vBond controllers, then you want to use a DNS entry that maps to multiple vBond controllers. Right? So use a DNS entry instead. So in the case of our class, we go to vbond.demo.local is what we use. So so if there were more than one vBond controller, then if one's not available, it automatically goes to the second. Now, this is the first time that we've actually seen these types of connections that are actually being created. So these are authenticated, encrypted connections between all the controllers and between all of the WAN edge routers and the controllers. So you decide whether or not it's going to be a DTLS connection or a TLS connection. Now, the difference between the two, DTLS just happens to be UDP based, and TLS, your transport layer security, happens to be TCP based. So with that comes the advantages and the disadvantages of both, right? If it's TCP based, the advantage is it's connection oriented and it's reliable. It's session based, in other words. And every time I send traffic, that traffic is acknowledged. But with that, the disadvantage is you got that added overhead. But DTLS, the datagram transport layer security, is UDP based. And UDP means you don't have the sequence numbers, you don't have the acknowledgement numbers, it is unreliable. So you don't have the overhead, but it's unreliable in its communications. Now, regardless though, it's still going to be an authenticated session and it's going to be an encrypted session. So really it boils down to you in your own organizations, whether or not you want to use DTLS between all the devices or whether or not you want to use TLS, your choice. Now you may have requirements that's placed on you that are governmental or healthcare or the financial industry where all communications has to be connection oriented. And if that's the case, then you'd have to use TLS. Otherwise, DTLS is your default. If you don't configure a protocol otherwise, then DTLS is by default what you're going to use. So that's the VBON orchestrator. Now, all of these other devices, all of the other devices that you have, vManage and all of your vSmart controllers, vManage will have a DTLS connection here, here, and here. It'll also have a connection to there. And if you had a second VBON orchestrator, then he also has connectivity here. Furthermore, all of your vSmart controllers has connectivity here. Let me make a change. He's got connectivity here. He's also got connectivity to there, connectivity to here, connectivity to there, connectivity to here, connectivity to there, and these guys have connectivity to each other as well. In other words, the vSmart controllers must have a full mesh of connectivity to all other controllers. They have to have a DTLS or a TLS connection from the vSmarts to all other vSmarts, and all the vSmarts have DTLS connections to VBON and also vManage as well. The one piece that's different is there is not a DTLS connection from VBON to VBON. They really don't know of each other. So if you're doing a manual process here, or the vManage, the managed service people already know this, that if I start adding information to this whitelist, you've got to also do it to this VBON controller as well. The VBON controllers have to be identical, but there's not a DTLS connection created between them. So that's the difference in terms of these DTLS connections. So your vManage, single pane of glass for the first day, the second day when you start doing some customizations to those initial deployments, and then day 2 and beyond, where you're modifying on the, and making modifications in your production environment. So that's day 0, day 1, and day 2. A single pane of glass. It does provide you with multi-tenancy, but multi-tenancy is not the default. We'll talk about multi-tenancy. The next time we'll actually talk about that will be on Friday. And it gives you centralized provisioning. So again, you are configuring the devices from within vManage, and you're pushing out device templates to all those devices from within vManage as well. So centralized. Not just policies and templates, you guys. Everything about your SD-WAN fabric is pushed out from vManage. Not just templates and policies, but everything. Everything is configured there. Typically, I'll get into more specifics about your options a little bit later on, but in a production network that needs to be a scalable deployment, everything is configured in vManage. It's the first place you're always going to go to from a troubleshooting and a monitoring perspective. And one reason for vManage being centrally provisioned is to push out software updates. So if you've got 45, 4351 routers and you want to push a software update out to them, you can from within vManage, assuming the devices are in that mode. But if they're not, then you'd have to log into each router and update each router individually, which becomes a tedious task. And certainly vManage provides you with a web interface and role-based authentication control. So you can configure a different users, I shouldn't say users, but administrators with varying degrees of admin rights. And again, the interface is just based upon a REST API. Can you have more than one vManage controller? Yep, absolutely. So with multiple vManage controllers, they do have connectivity. There's a message bus that's established between the two of those. So all configuration statistics are replicated across this data bus to each of the two different vManage controllers. And this is just kind of broken here a little bit, but all of the vManage controllers has the same consistent knowledge within the same cluster as other vManage controllers. Now, why do you need more than one vManage controller? Well, part of it's going to be based upon the sheer volume of WAN edge routers that you have. So if you've got less than 2,700 data devices, then you could have a cluster, a vManage cluster of a primary and a secondary operating in active and standby mode. But if you've got more than 2,700 devices, then you'd still have a cluster, but they would be in active mode instead of active and standby. And if you've got less than 2,700 devices, in theory, you could get away with just a single vManage controller. Now, if you have a cluster of vManage controllers, notice that this says that they have to be within 40 milliseconds of latency of each other. So between these two vManage controllers, likely they're going to be resident in the same data center. And if your two data centers are geographically, West Coast and East Coast, and you can't keep the latency between Eastern and Western region within 4 milliseconds, and if you needed to have a cluster, then you would merely have a cluster on the Western region and a cluster on the Eastern region. Because you could not keep them in sync if the latency is more than 4 milliseconds. You guys, I need to step away for a couple of minutes here. I hate to abruptly interrupt you, but I need to take a quick trip to the room here for a second. I'll be right back. If you guys need to also go 2-3 minutes tops, I'll be back. You guys, sorry about that abrupt interruption there, but sometimes you just gotta go. All right, so we talked about the
Right.
orchestration plane and the management plane. Yes, it's control plane next. Yes.
Yeah, so if you're in a cluster mode and you've got over 2,700 devices, what's the limit for those devices on that cluster?
Haven't seen that number.
Okay.
I mean, I honestly just haven't seen how big can it be. I mean, the reality is once you start getting, way beyond, I don't even know what the upper limit happens to be. I have a document that I received from Cisco not long ago that might give us upper limit recommendations, but I don't know of an actual number. So, and the reason is because once your performance starts degrading, then you just start adding multiple additional vManaged clusters, and then literally the size of your SD-WAN fabric can be unlimited at that point. So, but I haven't. I've got some recommendations from Cisco, and I don't have them readily right now, but I can get them for you. But
So if you lose one of those, so if you lose a vManaged controller in one of those clusters and it fails over to another set of clusters, maybe in another data center, I mean, is that the behavior it's going to, because it's not going to be able to support anything less than, or anything more than 2,700 devices. So it'll fail over to another cluster if you lose one of those vManaged controllers, correct?
If you lost a vManaged controller, the failover would occur. And if it's active standby, then the amount of time for that failover would be a little longer than if they were set up an active. So, yeah, I can just give you some of the recommendations I've got from Cisco, but I don't actually have hard limit numbers that says the number of data device can be this number in a cluster. That number, I've never seen that number published. So.
Okay. Thank you.
Oh, you're welcome. So your vSmart controllers, same thing here. So the only limitation we have for vSmart controllers is no more than 20 vSmart controllers in any one vManaged cluster. So if you need more than 20 vSmart controllers, that alone would be a requirement for multiple vManaged clusters in its own right. So your vSmart controllers, they provide us with our control plane. So notice it says the first bullet item there is it facilitates fabric discovery. Now, the fabric discovery is going to be from the perspective of your WAN edge routers. How are the WAN edge routers communicating to each other, right? That's going to be by way of IPsec tunnels. So we know enough already to make a distinction. Traffic that we have that is from the WAN, from the controllers to the controllers, from here to here, here to here, here, there. Everything in red there is going to be either a DTLS connection or it's going to be a TLS connection. Now, communications from the routers to the routers, I'm making that blue. All of this is going to be IPsec tunnels. So connectivity is different. Now, technically, DTLS and TLS, those are tunnels as well. But I'm preferring not to use the terminology tunnel when I discuss TLS and DTLS because I don't want that to be in confusion with what happens between the WAN edge routers themselves. So yeah, these DTLS connections, they're using IPsec as well. But those are DTLS connections, they're really tunnels, but these are IPsec tunnels. So this is helping me form my control plane. And the connectivity for IPsec tunnels from router to router, those are forming my data plane. So there needs to be a distinctive difference between those two. So I'm just using terminology for tunnels when I discuss the data plane, and I just use the terminology sessions when I describe the connectivity on the control plane. because it's two different implementations. DTLS between the controllers and between the controllers and the routers, and between the routers are IPsec tunnels. Just kind of make sure you guys kind of know the differences there. Now, even though we've got 3 transports here, that's still SD-WAN. So these routers have connectivity across each of those transports to each of those respective controllers. Likewise, from WAN edge router to WAN edge router, they've got connectivity across those same transports, right? At least by default. So the transports are used for DTLS connections to the control plane, and those are also used for IPsec tunnels or connectivity router to router to the data plane. So the control plane functionality is maintained in the WAN edge routers because the vSmart controllers, they disseminate control plane information between the routers themselves. So these guys are sending information and updates to all of those WAN edge routers across each of those respective transports. Now, let's kind of talk about volume of traffic here for 1 second. This is going to dovetail off of that last conversation we had about 2,700 data devices, right? And exceeding that. Well, on day-to-day, moment-to-moment, minute-to-minute communications, how much traffic is communicated from the vManage controller to these WAN edge routers, right? That is management information. That is configuration information. So if you're not making any configuration changes in the network, the amount of information exchanged from vManage to those WAN edge routers is minimal. There's very little traffic day in and day out going between vManage and those routers. Now, the routers themselves, they're sending updates. Anytime, you know, the SLA requirements, for example, are changing, they're giving status information to vManage. So there's actually day in and day out more traffic sourced by the routers to vManage, so that vManage using the dashboard can be up to date. Same thing is also going to be true for the control plane. How much information is exchanged from the vSmart controllers out to the branch routers when the network is stable? And the answer is very little information is actually exchanged. So, you know, looking at how many routers are there, that's because of an upper limit of something that needs to be communicated at the same time to all routers. Otherwise, you know, if it wasn't for that, you could have an unlimited number of routers in vManage or in vSmart controllers. It's just that if something were to happen right now and vManage has to push something out, you know, no more than 2,700 devices can any one vManage controller be required to communicate with. And again, that also is the vSmart controllers as well. So, but on a normal day in and day out, the network is stable, nothing's really happening, no changes are being made, then, you know, the amount of information exchanged from the controllers to the WAN edge routers is minimal. So I just want to kind of convey that to you guys. So the control plane distributes the data plane and application-aware routing policies out to the WAN edge routers also. And your control plane policies, all control plane policies, not data policies, but control plane policies, they are configured in vManage, pushed out to the vSmart controllers where they are implemented, where they're enforced. So control plane policies are enforced in vSmart. Data plane policies are still, they're configured in vManage, they're pushed out to the vSmart controllers, and then the vSmart controllers pushes those data policies out to the WAN edge routers, and they're actually enforced on the WAN edge routers themselves. So you see, when you start talking policies, you've got to be really specific of what kind of policy is it you're talking about to determine where it's enforced and where it is actually implemented. So by having this separation of data plane from control plane, now these routers down here, all they've really got to be concerned about is data forwarding. The vSmart controllers is telling them what their topology looks like. The policies are telling the WAN edge routers which IPsec tunnels are allowed and which ones aren't. In other words, hub and spoke topology is opposed to a full mesh topology. So this is going to dramatically reduce your control plane complexity. So now instead of having a routing engine running from here to 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 here and vice versa, now we're just looking at a data plane. All those decisions of how routing is going to work is in the vSmart controllers, merely pushed down to the WAN edge routers. And yes, you can have more than one vSmart controller, as is indicated by the slide there. So they have permanent connections with all devices. Now, I use the terminology permanent here because we have one connection that is temporary or non-permanent. And that is a connection that you have from the WAN edge routers to vBond. That connection is a temporary, or if you prefer saying non-permanent, that as well. As soon as I call home, brand new router, as soon as this brand new router calls home, you powered it on, the first thing it's going to do is set up a connection called home to the vBond orchestrator, your vBond controller. If the guy is whitelisted, again, if that whitelist includes that device, then a DTLS connection is going to be created between these two. They're going to do a mutual authentication between the two. They're going to compare organizational name information between the two, and then the DTLS tunnel gets brought up. Once the DTLS connection is brought up, that means that first and foremost, mutual authentication was successful because of the whitelist. The whitelist allowed this mutual authentication to be successful. Once that happens, this DTLS connection to vBond has a singular purpose. Right now, this brand new WAN edge router that you just powered on at a branch location has no clue who his vSmart controllers are or who his vManage controllers are. So the vBond says, here you go. Here's a list of all of your vSmart controllers and all of your vBond and all of your vManage controllers. Then this connection gets torn down. I don't need you anymore. The orchestration process from that one router's perspective has been accomplished. Now that same router across your transports then will set up DTLS connections to vSmart and also to vManage as well. And those will be permanent DTLS connections, just like the connections that's in place already between vManage and vBond, vManage and vSmart, and between vSmarts and vSmarts to vBond. Those are all permanent DTLS connections. They never go down. So kind of think about that in relationship to dynamic multi-point VPN. A lot of people go, isn't this similar to dynamic multi-point VPN? Nope, there's nothing dynamic about it. These are permanent connections between all the controllers, and they are permanent connections between the vManage controllers and the vSmart controllers with the WAN edge routers as well. So each vSmart controller acts independently of the others, even though all of the vSmarts have DTLS connections between them. Each vSmart controller has its own visibility of the network, and it acts independently of the others. So therefore, it's required that all three of those, or all of your vSmart controllers, be implemented in a full mesh of connectivity. We've got to make sure that the routing table information is fully synchronized across all of your controllers. Because think about it, these may be three vSmart controllers in one data center, you may have 3 other vSmart controllers in another data center. By default, any one edge router, any one WAN edge router will establish DTLS connections, but to only 2 vSmart controllers. Even though I have 6, he's only going to establish connectivity to 2. Now, that's the default behavior. Do you want him to set up DTLS connections to all of them? That is completely up to you, or maybe only to 3. That is your prerogative. But the default behavior is he only connects using DTLS connections to 2 vSmart controllers by default. Now, even though he has connectivity to 2 vSmart controllers, he's only going to be installing routes from only one of them. The other one is there. He knows about it. A permanent DTLS connection is created, but he's only going to be installing routes from one of those vSmart controllers. And guess what? You have absolutely no control over which of those vSmart controllers I'm downloading, installing routes from. It's just as long as I've got connectivity across one of my transports, that's all that's needed. Now, if I lost this guy, then he would install routes from another vSmart controller. If I lost both of those guys, I would install routes from another vSmart controller. And so it's dynamic in sense, but all of the vSmart controllers have to have permanent DTLS connections or TLS connections between them all, a full mesh of connectivity. And the reason for that is because the routing tables must be consistent. They have to be synchronized across all vSmart controllers. So the way that this is actually done is, it's up to the vBond orchestrator. So even though you may be not using a managed service, but rather doing an in-house management, remember the calling home of a brand new router to vBond, that is only if you're using a managed service. If it's an in-house managed service, you're adding it to vManage. You're not adding anything to vBond. But vBond's still important. And here's why. Assuming that you've got a router right now that's got a DTLS connection to let's say to those 2 vSmart controllers. And right now I have downloaded and installed all of my routes to that vSmart controller. Well, this vSmart controller is in sync to some other WAN edge routers, and maybe this vSmart controller is in sync with yet other WAN edge routers. I've just downloaded my routing tables from here. We've got to make sure that the routing tables in the other 2 vSmart controllers are in sync with this one. So imagine I have a network outage down here. I'm going to communicate that information to the vSmart controller that I'm in sync with. What he's going to do now is he's going to communicate that change to this vBond controller, and that vBond controller then keeps all the rest of the vSmart controllers in sync. So that the routing tables, regardless of which device you're downloading your routing table information from, is in sync with all vSmart controllers, and all the vSmart controllers have a permanent DTLS connection or TLS connection with each other. And as I said earlier, no more than 20 vSmart controllers are available in any one domain. So, as I said earlier, any one WAN edge router is connecting to up to 2 vSmart controllers by default. And that's something that's changeable, but that just happens to be its default behavior. And you have to have a mandatory full mesh of DTLS connections between all of your vSmarts. Now, that's not anything you have to worry about. That is SD-WAN behavior. As long as this guy knows about all 3 of them, then they will be allowed to establish DTLS connections among themselves, as well as vManage to all of those guys as well. So that's just the inherent behavior of SD-WAN. It's not anything that you have to really worry about. It's there. Now, here's where it does have a meaning though, an importance to you. Remember I was telling you earlier that I have DTLS connections to all of my vSmart controllers across each of my transports. And for this router to be functional if all I have to have is connectivity to one of my vSmart controllers across one of my transports. Now, where the mandatory part comes in here is when changes are taking place. So, granted, as long as one of my transports is functional and I can set up across that transport connectivity to my WAN edge routers, the data plane stays intact also. But where this mandatory part comes in here is when you're wanting to do changes. So all of your changes are going to be done to device templates in vManage. So if you're going to make a change in vManage requires a connection to vBond and all of the vSmart controllers before he can actually push a change out to the network. If any one of these controllers is down right now, and you're trying to make a change in vManage, the first thing vManage will always do is check the status of all the controllers before he will actually push a change out. Maybe it's a configuration change to routers, but he will not push that change out if any one of the controllers is not up and operational. So if you make a configuration change in vManage and you try to push that change out to 1 or 2 or 50 routers and it fails, the first thing you want to look at is make sure that all of the controllers are up and operational. Now see, that's the difference from what I described earlier. This guy has a control plane functionality as long as one of my vSmart controllers is up. But if that were the case and 2 of my vSmart controllers were down, this would never happen from vManage. So the control plane is up and functional from the WAN edge router's perspective, and data plane functionality continues. But during that time, you would never be able to source a change that affects any one device from vManage. Because like I said, the very first thing he does is in the task view, he's going to try to make sure, check DTLS connectivity or TLS connectivity to every one of the controllers. If one of those controllers is not up, and it should be, that push fails. So just kind of an FYI for you. More information about that will come though. And so these are all permanent connections between all the controllers and between all the controllers and the WAN edge routers. Those are permanent DTLS connections. Now, there is no limitation other than the maximum 2,700. Kind of think about that. If you had in your production and network 2,700 routers, then this vManage controller is going to have 2,700 DTLS connections to each of those respective routers, one across each transport. So if you happen to have 3 transports, that's going to be 2,700 times 3. That's how many permanent DTLS connections he's going to have. So the number 2,700 is a number that was created by Cisco for, again, maximum type of functionality. So as I said earlier, as long as one vSmart controller is present across any one of your transports, the network operations will continue uninterrupted from that one WAN edge router's perspective. However, if you've got outages between vSmart and any one of those controllers, changes are not permitted during that time. Okay, so usually a question comes up about that right now. Yes, that's exactly what I mean. You're in the middle of trying to push a change out to a router that needs to be changed. And one of your vBond controllers, one of your vSmart controllers is down right now. Yes, that means you cannot make a change to that router during that time. Can I get around that problem? The answer is yes. If you wanted to deactivate that say it's a vSmart controller. If you deactivate that vSmart controller, you can remove it from vManage's inventory, and now you can push those changes out. And then down the road, if you want to add that vSmart controller back in again, he will automatically eventually be in sync with the rest of the vSmart controllers anyway. So if you needed to make a change right now, that's what you would have to do. You would have to make sure that vManage no longer knows that vSmart controller even exists. So it would have to be deleted. Now, process of putting it back again, you're going to learn how to do that this afternoon. Okay, so finally, our data plane. And then once I finish the data plane, we'll stop there and we'll take a lunch break. We're coming up on 1:30. So your data plane is your WAN edge routers. That's connectivity from WAN edge router to WAN edge router only. Those can be either vEdge or your C-edge routers. It provides you with secure, authenticated, encrypted connections to all other WAN edge routers, at least by default. So anytime you hear the terminology connectivity to all other WAN edge routers, that means that it's a full mesh, right? So if you want to alter that behavior, that requires that you implement a policy, some kind of a policy. Now, first time we've seen this, the control plane connectivity with your vSmart controllers is done so using the overlay management protocol, referred to as OMP. So I like to just call OMP the routing protocol of SD-WAN. So what you have running now on each of these respective transports from these routers, again, across each transport, that's OMP. Now, back behind this router here, he may be connecting to another router, connecting to another router, connecting to another router. And these routers back here, all of these routers back here, they may be running BGP, or they may be running OSPF, or they may be running EIGRP, right? But the only protocol that's supported across this SD-WAN for communication to your vSmart controllers is OMP, the Overlay Management Protocol. So I'm going to mention something now, and hopefully it'll make perfect sense to you. Just comparing this to something we already know. If you've got a router here, and behind this router is connecting to other routers, to other routers, to other routers, and over here you're running OSPF. And then this guy is connecting to another router, connecting to another router, connecting to another router, and so on. And everything back here is EIGRP. And you want this router here to be able to know about routes that exist on these routers back here. What do you have to do? It's obvious, right? You're going to have to redistribute OSPF into EIGRP and redistribute EIGRP into OSPF. Well, now, let's say that we're running OSPF back here. Now, this router here becomes this router. So I'm running OSPF behind the router here, and the protocol that I have running here is OMP. Guess what you're going to have to do? You're going to have to redistribute OSPF into the OMP, and you're going to have to redistribute OMP into OSPF. Because you've got a router here also running OSPF as well. So you got OSPF back here, you've got OSPF back here, but there is no router to router connectivity across SD-WAN, is there? My control plane is my vSmart controllers. They understand OMP. So I'm going to have to redistribute OSPF into OMP. So these guys will know about these OSPF originated routes so that we can advertise OMP back into OSPF so this router can advertise OSPF information to his routers. So it's a mutual redistribution. So OMP is the overlay management protocol, and the underlay routing protocol is BGP, OSPF, EIGRP. Now, in addition to that, behind these routers, you could also have static routes. You could have directly connected routes that you could also advertise into OMP as well. Not to mention VRRP. So VRRP could also be implemented as well. Now, that's the virtual router redundancy protocol. In classic environments or in traditional routed environments, we've used, and most of you guys probably have used HSRP, the Hot Standby Routing Protocol. So VRRP is the industry standard equivalent of HSRP. And that is what's implemented in these WAN edge routers, including your C edges. HSRP is not supported. There is no plans to support HSRP going forward. So VRRP is your router redundancy protocol. And if you think about it, what it really means is default gateway redundancy. That's really what HSRP or VRRP, what they're really doing. But that's what could be implemented on your WAN edge routers also. And these guys are going to export their performance statistics to vManage, so that vManage can keep an up-to-date running tally of drop packets and error frames and transmitted received octets and whatever other application-aware routing information that you may have as well. So statistical information is sent to vManage across those DTLS connections, not across those IPsec tunnels. And these WAN edge routers, they do support ZTP, and they also support plug and play as well. You could have virtual or physical routers, anything up to 10 gigabit in speed, at least for the physical routers. And what if I wanted to have a pair of routers? So here shows you a data center deployment here, a pair of routers. Here is a campus location with a pair of routers, or branch location with a pair of routers. It's one router or two routers only. So no need for any more than that. So you could have redundancy there, because if you had a single router at a branch location, you still have transport redundancy, right? You've got transport redundancy, but what you don't have is router redundancy. So at a branch location, if I lost one router, now you've isolated the site. So by having a pair of routers there, I've got the same connectivity across a pair of routers. I lose one, I still have functionality from the other. But the DTLS connection is created from each router of your two at a branch at a site that is connecting across your DTLS connections to each of your vSmart controllers as well. So now, if it's a hub and spoke topology, you'll have DTLS connections across each transport to each of those routers. So they're separate DTLS connections. Okay, so this is the routing protocol of SD-WAN, so kind of a new topic. So this is where we'll stop right now to kind of begin our afternoon session. So I do need to run out and run some errands, unfortunately, for you guys at my lunchtime. So we're all going to have to take our hour break at lunchtime today, and I'll be back maybe a little bit before the hour's up, but I'll need a good amount of time to run my errands. And so I'll be back as soon as that is over. I'll set us a timer as I did this morning, so that if you do leave and come back, you'll see how much more time is available for our lunch. So I'll put this 60-minute timer on there. Let me put us back where we should be here. Right there we go. All right, so you guys, I will see you in an hour. I'll set our timer going now.